So, units raised to a power. Units act like variables, x's and a's and b's and stuff, and so they can also be raised to a power. And so we will sometimes have to convert units that are raised to a power. So how do we do that? So let's just remember that meters cubed, which is a unit of volume, meters cubed is the same as meters times meters times meters. If we had centimeters squared, that's centimeters times centimeters. When we're converting, we have to take that power into account. And so we have to raise the conversion factor to that power also. So let's do an example. An automobile engine has a displacement, which is a measure of the size of the engine, of 289.7 cubic inches. What is its displacement in cubic centimeters? This is a unit conversion problem. They're giving us a number in one unit, and they're asking for another unit. Always read the problem all the way through, and then identify the numbers in the units. So here we've got this one right here, 289.7 cubic inches, and then we've got cubic centimeters. What's another way to write cubic centimeters? Centimeters cubed. So we only have one number in here, so that makes it pretty easy. We're starting with the 289 cubic inches, and we're going to cubic centimeters. So there's our map, 289.7 cubic inches, and we're going to go to cubic centimeters. When you're planning out your map, initially overlook the cube, the exponent. Do we know a relationship between inches and centimeters? We do. We know that 1 inch equals 2.54 centimeters. If we know that, then we can do square inches to square centimeters or cubic inches to cubic centimeters. We need to know the relationship between the base units, the unit without an exponent. So let's set this up and look at it. So our pattern was we're going to start with this 289.7 cubic inches, and then we're going to put centimeters over here. Now there's a couple different ways to think about this. So I'm going to show you the more expanded version first, and then the more concentrated version. So if we initially just ignore the 3 and go inches to centimeters, then this is the conversion factor we put in there, right? This inch down here is going to cancel one of those. So I'll put this in a different color. So this is, the unit here is inch times inch times inch. That's what cubic inches is, right? So one of these is canceling with that. There's still 2 more. How can we get rid of those? Well, we could put this factor in again. So if we put in centimeters per inch again, this will cancel one more of those. So we need another one. This is weird, huh? This will cancel the third one. I'm showing you the long way, and then I'll show you the short way. Now, before we don't have any numbers in here yet. We got all those inches to cancel. What's the unit we're going to end up with? Centimeters cubed. We have centimeters times centimeters times centimeters. Centimeters cubed. So let's put the numbers in. So it's 2.54 goes with the centimeters, and 1 goes with the inch. And it's in there. That was a bad 4. That's not any better. There we go. So on our calculators, we're doing this, and we've got 289.7 times 2.54 times 2.54 times 2.54 equals and the calculator is showing me 4747.332441 unit cubic centimeters. Then we're going to practice our significant figures all semester. How many sig figs should our answer have? 4. 289.7 has 4 significant figures. Centimeters to inches is exact. So, I didn't leave myself much room. 4747 cubic centimeters. That's our final answer down there. Now that may seem a little cumbersome, right? But it works. Okay? Does everybody see and understand what I did on this one? This is the more straightforward, obvious way. Sometimes straightforward and obvious is a little tedious and involves walking around in circles a little bit. So is there a different way we could do this? Yeah, there is. So I'm going to go up on top here and use a slightly different color. So 289.7 cubic inches. Good grief. Okay, I want cubic centimeters on top. I want cubic inches on the bottom. I'm writing those cubes in there, but the number comes from the relationship between centimeters and inches. There's 2.54 centimeters in an inch, but because the unit is cubed, the number has to get cubed also. Here's another way to think of it. So centimeters up here, inches in the bottom, 2.54 centimeters per inch. I'm going to cube the whole thing. That's another way to think of it. That whole thing cubed, is the same as writing it out 3 times. The mistake that students frequently make, though, is that they forget to cube the 2.54. The number has to be cubed as well. Because 2.54 centimeters is 1 inch. But if you take 2.54 centimeters and cube it, it's not still 2.54. It's a different number. So some of you have a calculator that allows you to cube things easily, and others do not. If you don't have something that allows you to cube, then just type it in 3 times. On the TI-30XA, there is a Y to the X button. Y to the X button, and so that's what you would use. Oops. So I would put in 289.7 times, see if I remember how to do this, 2.54 y to the x, and I tell it 3 equals, and I get the same number. That's maybe a more elegant, a faster way. And if that makes sense to you and you can do it reproducibly, by all means do it. Yes. I didn't even see that. Yeah, there is on my TI-30XA, thank you for pointing that out, there is an X cubed button. So that'll work as well. 289.7 times 2.54. On the 30XA, it's the second function on the 1 button. Equals, same number, 4747. This business of cubing, it works the same with squares. Raising a unit to a power will come up a little bit. Okay, it'll come up a little bit. This is not a big deal in Chem 20, but I need to teach you how to do it. Converting units and learning dimensional analysis is a big deal. Units to a power, little deal. Okay, any questions? No? Common mistake is students forget to cube the number. Now, another common mistake is students will look at this number and they'll cube the 289.7. No. This cube applies to the unit only. That does not mean that you cube this number. Okay? This is 289.7 cubic inches. If I want the number cubed, I have to put parentheses around it and cube the whole thing. Okay, so some people forget to cube the number, and then other people go cubing numbers they shouldn't cube. We fall off the road on both sides. Oh wait, here's another example. How many cubic inches in 3.25 cubic yards? What unit are we starting with? We're starting with cubic yards, and what are we trying to find? Cubic inches. So to identify the conversion factor we need, ignore the cube. What's the relationship between yards and inches? 1 yard is 36 inches. Now, if you didn't remember that, but you remembered 3 feet in a yard, 12 inches in a foot, you could do 2 steps in here. So a yard equals 36 inches. Because we know the relationship between the units that are not cubed, we can do this with the units that are cubed. So over here, 3.25 cubic yards. And then I'm going to put this in without cubing the units. I want inches on top, because we're going from yards to inches, and then yards go in the bottom. The relationship is 36 inches for 1 yard. The units, though, are not going to cancel out correctly, are they? No. So I need to cube the whole thing. And you may look at that and say, well, you know, that's not real obvious to me how the units are going to work out. So another way that you could write this is, okay, this is cubic inches, cubic yards. The numbers have to be cubed also. That might be a little easier to see how the units are canceling out, that yards cubed cancels yards cubed. What is 1 cubed? Just 1. 1 times 1 times 1 is still 1. So what we have here is we've got 3.25 times 36 cubed. We get a really big number. 151,632 cubic inches. Are you getting that number on your calculator? Okay. Now, does that mean that if we measured 3.25 cubic yards, we would know it to the nearest cubic inch? No. We need to round based on our rules of significant figures. How many significant figures should the answer have? It should have 3. So is it 152? No, it's 152,000. We can't just knock off zeros. We're rounding in the thousands place. We're going to keep 3 significant figures. So we're going to keep the first 3 digits. We're going to keep up to this 1. That is above the ones place. Tens, hundreds, thousands, 10,000s, etc. When you're rounding up there, scientific notation first. So this is 1.51632. Got ahead of myself. 32 times 10. The understood decimal point was over here. 1, 2, 3, 4, 5 times 10 to the 5th cubic inches. So that rounds to 1.52 times 10 to the 5th. I didn't leave enough room. Cubic inches. I had all that space and I just wrote too big because I had all that space. Any questions? In scientific notation, the decimal point always goes after the first non-zero digit. You'll have a number other than 0 and a decimal point. In scientific notation, always, always, always. Be careful when you round numbers. We do not significantly change the value of a number by rounding it. You can't change 151,632 to 152. And if you like that kind of stuff, we can do some business transactions, and I'll make a lot of money off of you.